16,000 years ago? I don't remember, barely remember it. Sorry? It was at least before COVID, which might as well be 16,000 years. Anyway, big thanks to KrampHub for hosting us again tonight. Is this the first time since that 16,000 years ago? Probably? Yeah? Well, glad we're all here after 16,000 years. So. We have a nice agenda tonight, pretty full agenda. But before we get into that, of course, is anybody here for the first time? Quite a few, nice. How many of you live, those of you who are here for the first time, live in or very near Utrecht, as opposed to coming in from somewhere else? How many of you came from farther away? Well, welcome. Glad you made the journey out here. So we try to occasionally branch outside of Amsterdam because we know there's gophers all over the Netherlands and the world. But if you don't already know, check out the Rotterdam Meetup too, if that's closer to where you live. They do one a little less frequently than us, but it's a good one too. If you're not already on our Slack, check out the Gopher Slack Amsterdam channel. You don't have to live in Amsterdam. I don't live in Amsterdam, but I hang out there. So. We'd also love to hear from you if you'd be interested in participating in presenting. We have room for lightning talks, which are 5 to 10 minutes usually, regular talks a little bit longer, and if you have some idea for another event, let us know too. We're also always on the lookout for somebody fresh to do the What's New in Go, which you'll see what that is. It's a recurring event that we do every time. It's fairly straightforward, simple format, so if you're new to presenting or you think you want to try it, it could be something for you to volunteer for. Come talk to me or one of the other organizers. Would the organizers raise their hands? So is it just the three of us tonight? Yeah, I think there's a few others, but they're not. I guess Ilya didn't make, his car wasn't working. So come talk to one of us if you're interested. So this is our agenda for today. I think I forgot to put in the little intro to KrampHub. You have something prepared to talk about, right? Tell us who you are, all the great stuff you've been doing the last 16,000 years. But right after that, we're going to jump into these. We have two lightning talks, one about intro to error handling, one about integrating TDD effortlessly in Go projects. I'm excited about both of those. And then a longer talk about private AI querying with Go. I'm really curious. Ernest always gives great talks, so I'm looking forward to, I don't know what the content is. I'm looking forward to it. Then we'll have a break, and then we'll do two more talks. The What's New in Go I just mentioned, followed by Go generics or let go generic, or let go generics. Did I say that right? I don't know, it's a cute pun in the title. I hope I didn't mess up my slide. You gave me the slides, right?
Yeah.
That was the PDF, yeah. That one. Okay.
So, short introduction to the hub itself. So, you can just use the arrow. Yeah, first up, who am I? I'm Arvid. I've been working at the hub now already for 6 years. Almost from the start. And that's really the one that was there from the start there. So, started out as a Java developer. And a little bit of a hybrid, but using Java and Go. As a little bit over almost 2 years, I wanted to do Sharp X over here. So a little bit of a switch to dash programming, more arrows, commands, etc. And I'm also a frequent visitor of the Go Meetup of these here, like English clients, know the guys from there. A little bit of our Go experience. I think we started over here with like 1.8, just from top point, which is before the time could Go modules, so we have to deal with that. So it was a good old tab, nice little tool. So we're using it for stuff like cloud functions, run services, tooling, whatever. So that's so what is KrampHub? Or what is KrampHub? So needs a little bit of a background story. So we're a daughter company of corporate startup, corporate spin-off of Trump, where Trump is a large agriculture concern in the east of the country. So they're in B2B sales. So they sell to farm to dealers, and who in turn are selling back to the actual farmers. So they had this very old web shop that needed to be rebuilt. That's where we come in. Instead of doing it internally within Varsveld, that's really the only decent company that did it over here. Outside of the governments of whatever was going on over there with the TV itself. So we were able to set up this e-commerce platform, as we call it, that's able to be reused by different tenants, where Kramp is one of the tenants, but we also got Makers, where Kramp is in the B2B, Makers is in the B2C. So they got a marketplace, and where Kramp is one of the sellers, but there's also lots of areas for direct selling from the manufacturers or from other dealers, or maybe from one of our competitors if they want to. So that's how we fit in, and what we kind of use to be the target market. It is what it is. So we're all cloud native, so we're all in, we're hosting everything in Google, on Google Cloud. We're using a lot of PubSub, we're using a lot of Go, we're using gRPC, GraphQL, it's all buzzword bingo over here, so Postgres, Elastic, Neo4j, Java in the corner, so we're having it covered. And if you're interested, we're always hiring. Please check out the site. Over there, talk to one of our recruiters.
All right. Thanks. You wanted to use your own.
Is this necessary?
Yeah. Very serious.
Should just gotten serious.
Yeah.
Yeah.
Did I get your slide?
I think you did. I sent them to Mikko.
No programming, well, copy parent. We have pair programming, now we have a pair presentation.
Yeah, I'm going to figure out where I downloaded it to. Or where, yeah, this Windows. Oh, I think Slack crashed. When I clicked the download, Slack was crashed. I thought it downloaded the best one. Mere seconds away from success.
3, 2, wow.
Yes.
Oh. Do I just use the arrows to navigate?
Yeah.
Okay, cool. Okay, cool, thanks. My name is Wojtek, and today I'm going to be talking about error handling with Go. This talk is aimed more at the people new to the language. So if you're a more experienced Go developer, this might not be anything new for you, but nevertheless, this will be a good opportunity to either refresh your memory or structurize the knowledge that you already have. Few words about me. I started to use Go around 4 years ago, and I haven't really stopped ever since. I'm currently working at 11, where together with my dear colleagues sitting in the audience, we use Go on a daily basis to run an entire live video streaming platform. Error handling is, of course, a crucial part of any programming language, and Go here is no exception. Go's unique approach to error handling is to treat errors as values, which in essence is supposed to make the developers handle the errors more explicitly, and is also supposed to reduce the amount of unhandled errors throughout the application. That's why this is a common pattern you're going to see all over the Go applications, and it might seem a little redundant, but from the Go creator's perspective, it makes a lot of sense, and it's very straightforward. So let's talk about what actually an error in Golang is. So an error in Golang is anything that fulfills the error interface from the built-in package. So in essence, any object that has a method called error, which would return a string value, can be used as an error throughout your Go app. There's a few ways to create errors. You can create errors on the fly with the errors package. Here we have a small example function which is dividing two integers, and in case the second integer would turn out to have the value of a 0, we are going to return an error. Not returning an error and proceeding with the division would lead to a small catastrophe. That's why this scenario needs to be handled, and you can use the errors package to create an error and return a simple static message. It is also a very good practice to define those simple errors with a static message as a sentinel global variable, which is going to prove extremely helpful when comparing errors. But this is something we're going to get to a little bit later. You can also attach some kind of dynamic data to your error with the FMT package. It works like C's printf. Where you just provide an argument and an operand. But sometimes there are the cases where you want to have some more complex data attached to an error. And as we have already established before, anything that fulfills the error interface can be treated as an error. So this opens up the possibility of writing your own custom errors. This is, my feeling is that this is not a very, very popular practice, but nevertheless it is very useful. Here we have a structure called custom division error, which has its own internal private variables and some methods. And as you can see, there is the error method returning a string, which makes this object pass as an error interface. Error wrapping is also an important concept when talking about Go's errors. And just as the name suggests, error wrapping is wrapping some additional context around the error value. So in this case, we have one function called division wrapper, which wraps over the division function. It doesn't really make sense, but for the sake of this argument, as you can see, we are wrapping the error returned by the division function with the FMT package, and there's this special operand %w, which has to be used in order to create a wrapped error. Otherwise, the error is not going to be able to be unwrapped, which is shown a little bit lower. And just like a wrapped gift, if you want to get to the inside of the error and grasp the value, you need to unwrap the package. And if in case you would use this method on an error that is not wrapped, it would simply return a new. And there's a few things that you should be aware of when creating errors. Errors can be returned as new, and this is actually the default value of an error. An error has to be always returned as the last return argument, and if an error is not to be of the nil value, the other return arguments of a function have to have their default value. So in case, as you see with the division function, if we return an error, the value of the integer, the other integer, is equal to 0. Oh, sorry, wrong arrow. Right. So, and as your application grows, you're probably going to want to have more control over what errors do your function return, and you want to act based upon what error is being returned. And Go offers you two ways of doing so. The first way of comparing an error is the is function from the errors package, which is technically not equivalent to the equal operand, because it's also taking care of wrapping under the hood. So in essence, it has the feeling that, okay, if the error is error division, then panic or do anything else. But in essence, if this error would be wrapped, it can return false. So it's important to use the errors package to compare errors and not rely on the standard operands, because you never know if an error is wrapped, and this can lead to some false results. And the second way of comparing an error is to use the as function, which in comparison to the is function does not compare errors by value, but compares them by type. So it would work similarly to as if you assert a type to an interface, but it also takes care of wrapping under the hood. So if the result of the as function is true, you get you assert the type to the target error, and you get access to its internals. Do you have any questions, guys? Yes?
Yeah, it just occurred to me, and I see it all the time when I'm programming, you cannot start your error message with a capital letter. Why is that? You also have them on your bullet.
Yeah, they should always be lowercase letters with no punctuation at the end. This is just the official guideline as far as I'm concerned, so I might be the wrong person to answer your question, but yeah, from my perspective, it's just the way it is. Maybe somebody here knows the answer to this question.
Yeah. The reason is if you do wrapping, and you may end up with your error message in the middle of another error message, so you don't want to say, you don't want a complete sentence that is later going to be treated as though it's part of an incomplete sentence. So that's the reason. It's stylistic, but that's the reason.
Yeah.
All right, so that's it. Thank you for.
If I may, I've got a question about the unwrap sheet. Could you please go back to it?
Yeah.
I was wondering, does the unwrap one layer? So, and what would happen if you have?
If you have
An
multiple
error
layers, if you have multiple layers, it unwraps to the core value of the error. So as far as I understand, if you print the error straight here, it's before unwrapping, it's going to print up the wrapped message. And if there were more layers of the wrap, I suspect it would print the whole thing. But if you unwrap it, it's going to print. You're going to get access to the core value of the error, like the lowest, the further one in the chain. Is that correct?
No, I would expect only one layer, so you can do it multiple times and look further down until you get to the end. And if you're at the deepest, then unwrap. I think returns nil, that there's no more deeper.
Right.
But this is from the.
You use errors as if you want to look deeper.
Yes, yeah. And errors is also looks deeper.
Yeah.
But if you unwrap, I think you just unwrap one layer. I think, but this is from memory.
We got a fact check here. So.
Both errors as and is will go until they have a match, and then they'll stop.
They
So
actually
they may not go all the way, depending on.
they match with the first encounter with type or value.
What will happen if you wrap the multiple errors and you try to unwrap it?
I think that's the same question.
Yeah, I think this is
form of the same question that was
Yeah.
asked. You want to Repeat the answer, or?
It's like a stack.
Yes.
So we expected to have like a step-by-step on the route that previous.
So like I think what you can imagine is like if you would have a GIF, if you would have like a Lego set and you wrap it once and then you wrap it again, so it has these 2 layers of paper. So like you unwrap the first one, but there's still paper underneath. So
I just got to the standard library, unwraps one layer. You can use it in a while loop as well to unwrap all the layers and iterate over them.
yes.
Are you allowed the %W? Are you allowed to use 2 of them in the same string?
That's a very good question. I don't know. I haven't really tested it with operands, but what I know that it's necessary to use it if you want your error. Yeah, do we want to try?
There's now the errors join.
Okay. So I'm getting an answer here that from Go 1.21 it's you're allowed to use multiple operands.
Wasn't it, or was it 20?
I know, it's 21 after we visit some.
It was when they added the.
I stopped at 120. So.
I think it was 21, or was it 20? 20. It was 20, sorry.
Oh, okay. So.
I saw that you create 2 types of error. One is fmt.error and the other is errors.new. Are there any differences of this type?
Which
For example, fmt.errorf, which is create an error. Also errors.new also create an error.
yes.
These 2 types are equal, or are there any differences about creating this?
I think under the hood, those 2 might be different structs, but in essence those are not exportable. So you only get the error interface. So from your perspective, those two are the same. There's just a different way of creating them. So for example, using errors.new, you are not going to be able to create a wrapped error. You can only create a wrapped error. Custom error, or if you use the FMT package. But like from your perspective, those 2 are error interfaces.
My name is Joanna. I work here at KrampHub, so with Marvin and everybody else. And I wanted to bring you a cautionary tale about testing, about my Go experience. So I'm from Portugal and I moved here to the Netherlands 7 years ago, and it was actually when my Go journey started. So I'm from 1.7, so I used Melody to manage dependencies. So yeah, very old, but yeah, very nice journey. So yeah, I wanted to bring you some good lessons that we learned about testing. So we had a situation here, and specifically I found that situation in some services on our team, that we were using service tests, and we were using them orchestrated using Docker Compose. And more or less they would be composed of a container running the service to test, a container with the tests, and then several other containers with our dependencies, Postgres, Neo4j, whatever you can think of. Our code to test was triggered using external APIs. So if it would be a message, we would build the message and then send it through it. And then the test assertions were done expecting directly the dependencies. And you see this and you think, oh nice. Which problems do you find with this? Well, a lot. We were starting to get frustrated because our tests, firstly, were taking very time to run. We needed to spin up a lot of containers, so our dependencies always +2. They were very difficult to run. We needed scripts, we needed to pass knowledge between team members. So we couldn't just simply pull up the tests on our EDA, go test all, and everything would run magically. We needed always to set up our dependencies separately. So you can imagine how nice it was for debugging and etc. Yeah, so this resulted that they were very difficult to maintain and understand in the end. We needed to do something. And so we rounded up that we needed to reduce the complexity of the tests. We needed to reduce the maintenance and development time, but that's very important if we want to do things quickly. We also needed to run them easily from the IDE without any configurations, so that in the end we could apply TDD and we could write the tests before we write the code. So we set up ourselves into a journey, just like Frodo in the path to the mountain with a ring in hand. And we divided the journey in several steps. So the first one, we wanted the tests to call the code directly. So we refactored everything, and now we are instantiating our dependencies, our code dependencies that we needed, and we are calling the methods directly that we need to test. So after this, we were able to remove the need of the service image from Docker Compose. Great, one less. But still, we needed more steps. We couldn't run the tests in parallel because we were using the same dependencies. So we needed some way to remove the need to use Docker Compose and have only one instance of our dependencies being shared for all the tests. And we also wanted to remove the JUnit style. I don't know if you know the Testify suite style. Yeah, we were using that everywhere because we needed code to clean up our tests, otherwise they would have interference with each other. So we wanted also to remove all of this boilerplate code so that our tests could be easier and we could write tests on an idiomatic way with our beautiful test functions. And we got to search and we found this. I'm sure you've heard about it, test containers. So we figured out that we would manage, it's a tool, basically a framework that you could use to create and clean up your containerized dependencies, specifically written for tests. And we found just what we needed. Just what we needed. So I won't talk much about how to use it because we won't have time. I can discuss some things with you in the end. But I can give you some tips that we've learned from our usage. So firstly, there's methods that could spin up dependencies using the Docker Compose file. Don't use them because they will just call the underlying Docker Compose via the API. So it would just basically do the same. So what we advise is that you set up each individual container in the beginning of each test. Don't worry about cleanup because there's a component called Riot that will detect if your containers are not used anymore and will clean them up. And of course, you may think, well, we have a lot of containers running on the machine. How am I supposed to map things correctly when I need to create a driver or anything? So they have methods. So internally, test containers will map a port that you will define that your service needs to spin up, to open. It's a random port internally on your host machine. So there's methods on package API so that you can retrieve that port and you can use that with localhost, of course, because host. So you can use that to connect to whatever you need to connect. But still, after we rewrote everything to use test containers, we were able to remove the scripts to set up the dependencies, so great. Now everything runs with Go test, perfect. We could finally run and debug tests via the IDE, which was great. We didn't need any other thing than just assuming that everybody will know to run tests in Go. But still, we found out that if we had services that we wanted to test that use many dependencies at the same time, the test could still take a bit to run. I forgot to mention that now, of course, the test can be run in parallel. So, what we learned from having too many dependencies is that sometimes we could reduce the usage of them on the tests. So, mocks are still our best friends. And we did end up mocking some of our dependencies. For example, communication mechanisms. We used GCP PubSub, and we used emulators on our tests that we would spin up. But those could be easily mocked. We don't need to test specific behaviors on them. So I'm sure you will find other examples on your code where you don't need to use a containerized dependency. So when you don't need to use it, don't use it. So yeah, just like Frodo, we dropped the ring, we killed the toil from our tests, and we are happy now, and we can write code, the tests before our code. I don't have any slide with questions, but I don't know if you guys want to ask something. I don't know if somebody wants to ask them. Oh, right. Yes.
So have you tried keeping, for example, the database?
Sorry, can you speak a little bit louder?
Have you tried keeping the database turned on, let's say, in between tests, instead of speeding up to avoid having to resort to mocks?
It could. There's also options that, for you to reuse the same container. So you could try and see if it could benefit. I personally think that, and I personally like to write tests that are atomic and self-contained. So you won't need that information elsewhere. If you need to set up something before the test, you need to explicitly do it before your test. Sorry.
I was curious about like the before and after picture. How long did it take to run the test suite? Like say you're on your laptop, nothing's running, you have to run Docker compose, blah, blah, blah. How long did it take to do that from start to finish? Before and after?
Okay, I can give you on my local machine like the correct numbers. We were mostly concerned with the fact that it was very difficult to run. For example, we needed to run the whole setup because we needed to run the scripts to set up the dependencies and then pull the tests. So it was very hard to run specifically only one test. So we don't have to run all of the tests all of the time now. We can just run one, for example. In terms of that comparison, it's very hard because we are using cloud builds, but I've seen savings of like some minutes. Depends, 2-3 minutes. But the benefit is not necessarily on the runtime. The benefits are on the simplicity, on the fact that you can debug and run tests easily, the fact that you don't need additional scripts or anything, and yeah.
Okay.
Oh, I don't. Yes, sorry.
Yes, I'm a little bit curious about how you handle the pipelines, because when you use this one, you will do this straight to the connection to Docker socket or something.
Will you use pipelines?
Yeah, it's some kind of automatize your testing.
You mean like GitHub Actions or
Jenkins,
something like
GitHub
that?
Actions.
Oh, yeah. My experiences with Cloud Build, I haven't used it elsewhere. From what I see on the test container Slack, they have a Slack, by the way. They have a test containers Go channel, so if you have problems, you can go there. People are very nice. If you detect a bug, they can also help you understand if it is a bug or not. From what I see, there's no issue. There was an issue, there is an issue still, I think, if you use a private repository. So if you are trying to use an image from a private repository, you could have problems. But yeah, I didn't find everything integrated smoothly, because Docker is set up for how they run. So it depends on your CI/CD does that.
So
Because it will-
So in Cloud Build itself, it passes along the Docker daemon and has access to the Docker daemon so that it can start all of those containers.
Yeah.
And you can set up the machines as big as you want. Over there, I think the default one is like a 2 CPU, 8 gigs or something like that. That will run everything. The bigger machines, those are available, will cost you a little bit more. With the standard machines, we're able to run all of our service tests or whatever.
Which pipeline do you use?
I usually GitHub.
GitHub Actions, it'll work out of the box.
I think so.
Yeah,
It just-
but it looks like some of the, for example, our companies block the Docker socket access.
Then you'll have problems, yeah.
They say you can
I
destroy
just
machine.
remembered something. I think for some providers, you will need to pass to enable some environment variables when you can't use because it needs privileged access. Somehow, I
Yes,
just.
actually, yeah, you're right. You just,
But those cases are on the documentation, and I'm sure if you go there and ask on Slack, they will help you if you have problems.
Any last question? Maybe a quick one, hopefully. So you made quite a few changes to the
Yes.
system, to the build system, or basically the whole software. So I was wondering how much time, effort it took to make those changes, and especially, for example, the mock stuff. It sounds like we have to refactor quite a bit of code. So that's one question. And the next small question is: did you also try approaches that didn't work? Did you try to make a change that for the testing improvements, but you had to abort the attempt because it didn't help?
I had to do that with one in specific. So, first question, it took a while. But also, it helped our code because in the end, it took a while because also our code was not correctly designed. So what I needed to do sometimes was to create interfaces for some dependencies. Of course, yeah. So all of the improvements have had great results in terms of code readability and all of that.
Did you know beforehand like what the tough subjects were, or did you find out along the way? Like, oh, this is a surprise.
Yes. That's why I'm telling you that, so that you can save a bit of time. But yes, it was a journey, and yes, it had to be step by step, as I said. I don't remember the second question anymore. I'm sorry.
The second one was about if you tried to make some change that you thought would be an improvement that didn't work out, so you had to basically abort the work. Sometimes you go in and you make changes, and then at the end you figure out, oh, this is not possible because some blocking issue.
Yes. Exactly the one where we were using. So we have an image that we built using the PubSub emulator. Some teams use it internally. So we had that image on a private repository, and what I found out was that we were enabled to connect to our GCP private repository, so the way that the code was being retrieving the authentication from the Docker config. I had a look at the code of testcontainers.go. It was very simple to change. But after that, I still had some problems, but it had to do on how this cloud build passed the configurations. Maybe if I spent more time on it, maybe I would figure it out. But also, I looked at the code and I was like, why am I trying to use a container for this? It's messages. It doesn't matter. So we just need to check if something is sent and if it contains the right information. So in the end, it was what led me to the last one. We don't need to use containerized dependencies for everything. It's easier, but it has its costs. And if you have a service, we have a service that uses, for example, a graph database. It uses PubSub to receive messages. It uses a Redis cache, and it also uses a Postgres database now. So, and sometimes you have dependencies that use all of these.
Let's see one last question over here.
So you mentioned a few services which you prefer to monk, but are there any sort of dependencies which you actually would advise against?
I think, I think databases are a good one, because you can also check your init scripts easily. So if it is a NoSQL store, it's just a bag with objects inside. So what are you going to test there? What is the special behavior? So those things you probably won't need. And even if you use a database or you don't have anything specific that you want to test, maybe you can walk it. Did you want to say something, Ravi?
We need to go on. One last quick question.
Sorry.
So you have, let's say, all the test data is in the test Docker, and you'll inject it to your environment or dependency. I mean, you're gonna clean up all the data after the test, so you could trigger it again, or you just keep it there?
No. Well, as I said in the beginning, I like to write self-contained tests. So I would prefer to clean up everything after. Test containers has a component called view. So it's a garbage collector of containers. So you will detect the containers for the tests that ended, and you will clean them up.
Even the data in your database will be cleaned up as well?
Yes.
Oh.
Yes.
The whole container will be killed.
Yes, the whole container will be killed.
But your database is not in. I thought you put it outside.
I guess this container is database, right?
Yes, it's a containerized database, so it's not your database. So it's a so it spins up a container with a database inside. So you will need to do everything. Create the schema, create the user, everything.
Takes a while.
Takes a while. Yeah. Not that much. Sorry.
No, that's great. Thank you so much.
Yeah, I was just thinking about all the new people here. I don't know me. So I've been in the Go community for quite a while now. I started Go in 2012, I think. I'm not sure 1.0 came out. Do you know?
No, it must be 2010, more than 10 years, right?
Yeah. So, but despite the fact that I have quite a lot of experience with Go, I'm not going to show you that much code today. I did put a bit pieces in there. And I wanted to share you something that we did in our company, an experiment using AI, because everybody is using AI, so why not be part of that thingy. And I wanted to share you some of the insights we got. And I also realized that AI, of course, is moving very fast, and I might not tell you something that you don't know, but it doesn't really matter. It's how we apply it to our system, and maybe it can inspire you to look at a similar solution. So before I start, I have to tell you a bit about where I work and why we do this. So I work at HE5. We are a SaaS company. We are in the business of skills management, so we keep track of skills of people that work in factories. So if you have a factory, you build cars, you have people putting them together, those people need certain skills, and then we collect those skills and make sure everybody is certified. That's all I'm going to tell you about HE5. But also what's very important to note is that we have a multi-tenant data architecture. So typically for a SaaS company, you run software on behalf of a customer, but you need to serve many customers, so your architecture needs to be multi-tenant. So, and of course, our customers want dashboards. So customers that we have, they use our system, they put in the data. This person has this skill, is this valid for that period of time, and we have groups of people, and we have departments of people, and managers, and so on. And at some point of time, those customers think, hey, we put a lot of data in your system, and of course we can view everything and we can maintain it, but we really want dashboards. Everybody wants dashboards. Nice pictures, graphs, showing trends, and so on. And I'm not sure if anybody here has spent any time writing these dashboards, but it's a lot of work. And it's difficult for two reasons. One is, we as a company, we don't know what you're going to ask. What kind of graph do you want? Maybe you want those numbers or pie charts or whatever. And the second problem is, it takes quite some engineering to put those things together. And so, we thought, a lot of engineering. So what if you have a conversation with your system. So just talk to your data. So that was an idea that we had, and we had a kind of little hackathon, and that went quite well. So we continued working on that, and yeah, I want to share with you where we got. So, so the idea is that you go to a system, and then the customer says, how many results are there? Results are the achievements on the scale. 2023 per month. And what you really want to see is this. Right? So I'm thinking of a question, I have a question. I don't want to look at all those dashboards to find a graph that matches my question. No, I want to pose the question and let the system figure out what you want to see. So how would you solve this? Maybe AI can help here. LLM, large language models, it's just part of the AI. And we all know about ChatGPT and all the other models that are there, where you can have a conversation with something that knows about your system and now knows about the knowledge of the world. But we thought, yeah, there are some constraints we need to uphold. Because every customer, they put their data in our system. It's private, right? It's their data. So we store it in an isolated data set, and separate from all the other customers. So if we're going to use AI, we can't just send all the data to Mr. Google or GPT or whatever, and train on it, and then ask questions. We can't do that. We can ask our customers, hey, do you mind if we send your data to Google? And most likely they would say no. So we need to avoid that. And also, the last one, very important, if it comes back with an answer, it should not try to, hey, maybe you think you want to have this answer, or it looks like this answer. No, it to be correct. Because a dashboard represents the data. If the graphs show a trending up, it should not say a flatliner or something like that. So in AI, it's called hallucination. It's a temperature parameter. Okay. So that was really, part of the constraints. So we can't send all the data to the customer, to the AI, but we do want to have conversation. What would you do? This is how we did it. So instead of sending the data, we asked the AI to translate our question into a SQL statement. So we can ask the same question in SQL to a data set. The data set, if you want, returns arbitrary table data. And then we need to figure out how to present that using the graph. Simple, right? Yeah, it is simple. It is nice. It works.
You make it sound simple, eh?
It is simple, really. There are some challenges which I'm going to talk about. So it's really, this word context, that's really important. Because our LLM, either be a GPT or we are using Palm, doesn't really matter. Still, it doesn't know about your data. It also doesn't know about the data structure. It doesn't know about your tables, relations between tables, data types, names. It doesn't know about it. But we can tell it about it. We can tell, and we are allowed to, because that's our information. That's not customer information. It's our information about the structure of the table. So we put that in the context, and I will show you in the demo later what the context looks like. But basically, we sent the schema of the data set to our LLM system, along with the question. How many results in 2023? And we tell them the table is achievements. There you can find the results. And the LLM figures out, by looking at the data set structure, what are columns can be used to filter the results. So let me talk to you, like I said, I have little pieces in Go, how we did this. So this is an example of the context that we sent. I mentioned just create stable statements. We just put the DDL and we send it to context. That's what we started. Later, we figured out not the best way to do it, but it already got some very interesting results just sending the DDL to And also, what also helped, maybe before I forget to mention it, is just to put some information about what we call aliases. So if the customer talks about results, and we know the table is called achievement, yeah, there might be a mismatch, so we put in some tips. But yeah, in the end, I will come to the conclusion later, but it's all about prompt engineering. Have you heard about the term? Should be the next skill on your resume. Prompt engineering. So, getting AI answers in Go. And yeah, there's a library for it. Can't help it, sorry. So, we are using the Google APIs at the moment, because everybody was using GPT. I thought, hey, why not use Tom? And it took quite some time to figure out how to use the API. It's not very well documented at the time, because Google was kind of in a hurry catching up with all the GPT things. So they put out stuff very quickly, but we managed to find it out. And so I put a yellow line on the line. So it's really important that you use an authenticated Google client. So you use OAuth 2 to authenticate with Google. There's a nice library that you can use as a client. And then you simply use a REST API. This is what the prompter is using to send data. And this is actually sending the prompts. Provided with the prediction context. There's a piece of text I showed you earlier, and the content in this case is just the prompt. And then you put together predict requests, and it's basically posting it and marshalling it. It's basic, simple, standard error handling code. The reason why I put this little arrow in is it really helps if you first read the whole body before marshalling it to a struct, because if the marshalling fails or you don't get a 200, then you still have the body to log. That's nice, because in the beginning we didn't understand what the responses were. Just a little trick for you. So we have covered the first part, sending the prompt to AI, getting back SQL. Sometimes. Sometimes you get markdown formatted SQL. What? And then you need to strip the markdown. You didn't ask for it, but that's the hallucination part, right? It tries to be smart. We don't want that. So what do you do? You add another line to your context. Do not return markdown. It works. It's just a little kit, you have to tell it.
Is that a better thing to do than to say only return SQL, because then it will not return markdown and it will come up with...
In the beginning you didn't think about it.
Yeah.
Of course we asked SQL.
Yeah, oh yeah, but then you got it
but
wrapped
it
in
returned
something.
a red markdown. Yeah. So now let's assume we got a proper nice statement. And but the next challenge is that SQL is not customer aware, because we were sending how many results do we have, and it says selects count star from this table. But it doesn't say for this particular customer. It doesn't know. We didn't tell them. It doesn't know. And you think it's very easy to put this customer aware thing, but that's not easy, because the query can be really complex. Lots of joins and God knows where. And where do you need to put the conditions? You see the problem? So you ask how many qualifications are there, it returns count. But I really want to transform it into that part. It is for a certain data set in a certain stage, and it should not be deleted. And it should be the latest version. That's information very private to our data set. that AI doesn't know about, but we need to have it. I tell you two methods that we tried. First we tried, okay, let's be smart. We will parse the whole SQL, and then we do patching of the AST. Do you know what AST is? Yeah. So so I found a very nice SQL parser, and you can parse the SQL. And then I created something what I call a read-write context. It's basically the visitor pattern that I walk through the whole AST, and then if I find some table where it's used, then I will add conditions to it. I won't go into all the details of this implementation, but still want to show you the basic idea. So we have this rewrite rule where you have a condition and an action part. And the condition checks, hey, am I at a node which I need to change? If that's true, I apply the action. And that way I can implement all kinds of rewrite rule structs that do different things to the AST. Already quite complex, right? And then I ended up with these 6 rules. Add a data set to, if there's a where, add a data set if there's not a where. And then I found out, oh, in this case, it uses something into account. Okay, I have to name the count, otherwise I can't get the column back. And then if there's an ID, it becomes very complex. It worked sometimes. But I had the feeling, this is going to take a lot of time to get it right. So what do?
Views.
Yes, AI. Ask my AI. Please, AI, rewrite my AI. But of course, then you need to provide the context. This is the context we gave. You are given the right SQL. Please rewrite using the following conditions. Add a data set, add a stage, add a version. For every join you find, do this, do this, do this. And the reason, do you know why it's a percent S at the end? Because the context is different for every customer. So we use a template as a template, right? So feed it ID in. This works very good. And this is just the first version, and we added more rules. And the reason why you add more rules is because it returns things that doesn't make sense. So you can change it. Can I mention you need to be prompt engineer? This is the reason why. So, so let's say, again, we asked AI, give me a better SQL, one that fits this customer. And of course, you have to challenge that you need to execute SQL. Well, that's of course being solved. I mean, just send the string to the database, and you get your data. But what do you get back from that SQL query? You don't know. Scary, yeah? So you let AI generate a query, you don't look at it. You just send it to your database.
Aren't you really afraid of sending stuff that is quite dangerous into your database?
Of course!
Drop table.
Drop table! I won't get into details, but of course you need to protect. But then, yeah, so let's assume it's a valid query. It's a nice select, it doesn't have side effect, blah blah. Then of course, you can send it to, we are using Spanner, by the way, for database, doesn't really matter. But the problem is, you don't know what you get in return, so you need to send the query and then ask the row what were the column names that you retrieved. And then you need to write something smart, I call it here the read into. You get a row, column name, and you know the data types, and then you figure out what to do. Basically, it's a map string to any, and hopefully somewhere down the line you can make some sense of it in order to create the table like right now. So we have to cover that. So you already know, I hope, what I'm going to say next. Doing that's the next step. Because what I'm going to use is of course. Because, so that's query we don't know about, returns data we don't know about. So we need to reason about that data structure. It could be a number, just a count. If you ask for a count, you get a number. If you ask for group, something results group by month, then you most likely get a table of 2 columns. If you ask about qualification details, you might get 20 columns. So yes, we used again AI to figure out, hey, is this something that can be drawn using a bar chart? Is it something we can show using a table? Or is it just a count? And the biggest lesson, I think, I'd like to know is that you can break down this problem into multiple steps. And not every step can be solved by AI, but a lot of them can. And we use it. So we tell it, this is the API of our graphing library, and this is the data. How should we call it? Now we get information how to call it. And of course, the first time it doesn't work, then you change the context because you are a prompt engineer, so you tell us how to do it. You give examples. If you give this, then please AI return this. Or another example and another example. And then it gets better every time. So these are some of the examples that we have. What is the type of question? Sometimes we ask for counts or records. We also have something that asks for events. We need to go to a different data set actually. We provide a lot of aliases to tables to make it match the language of the customer. If that person is asking about skills, but internally we use the term qualification. Yeah, good to have that. The last part also we asked AI to find the best labels given the table to use in our graph. So maybe it's time to demo.
This tells the Go compiler, the Go system, that you want to build an array of with whatever number of elements are defined. So the question we're asking here is how many elements are defined? That's what we're asking, right? What's the length? Who thinks the answer is 8? 9? 10? Who has any idea what the answer is? Who wants to give a guess? Go.
6.
Sorry?
6.
6? No. 13, no.
33.
Any other guesses?
-1.
-1, no.
4. 12.
No.
4.
No.
30.
It's 14.
No, I think
Now, why? Some people were close.
Of course.
So you've all seen slices and arrays where you just do this, right? This is normal. Index 0, index 1, index 2. But what the heck is this colon nonsense blue line? This says index 12 equals 9. And index 7 is 5. But what's this one? It gets whatever this index is plus 1. So the largest index is 13, which means there's 14 elements in the array. Don't ever write code like this, please. I'll fire you. Alright, let's do it go, right?
Jonathan, maybe plug the Slack channel on.
Sorry?
Maybe plug the Slack channel on.
Yeah. Oh yeah, so if you didn't know the answer to that, it's because you weren't on our Slack channel where I posted a very similar version of this question just a few days ago. Yes?
I got confused by the dots. Does this make
Yeah.
a difference? Or
That's one of the 6 things in that code that should confuse you. Hey, there he is.
Cool. Thank you. I'll do the what's new in Go this time. We are already quite late, so I'm going to speed run it, whilst not talking too fastly, hopefully. My name is Koen. I work together with Eric at Pokey. I'm a backend engineer since forever, and I've been using Go almost since release, I think, since 1.0. And what's new in Go since last time? Mostly the implementation of the toolchain, runtime, and libraries. And one big change to updates, an update to updates, is from now on the initial version will be 1.n.0. Previously the version would be 1.21, and then the next minor update would introduce the minor. But now the minor update will always be present as 0 from now on, if you use it on a version like that. For the compiler, big update is that the profile guided optimization is now ready, generally available and on by default, which means if you make a profile recording of your application in production, which is fairly easy to do. So if your code is running on load, you make a profile of that, and you name that default.pgo, put it in your main folder. The compiler will automatically use it and optimize your binary based on that type of load. Which means, as the compiler is now compiled using this, using its own profile data, that the compiler is about 6% faster compiling because it uses this new technique. And your app, depending on your app, will see between 2 and 7% performance increase, just enabling this option. We did an experiment in Pokey, which is completely useless because we're definitely not CPU bound or anything, just wanted to have fun. But we record profiles constantly and write it to an S3 bucket, and we get that every once in a while, just to see how that would work to get this in a flow. If your app is CPU bound, I highly recommend this to get a free, like almost 10% performance increase. Then language and library changes. The new built-in min, max, and clear are in. Min, max does what you expect them to do. They give the smallest or the largest value. What is very cool is if you mix types, you can give it an int and a float, and it will give you the smallest one. I didn't know, I had to test it out. If you give it 2 integers, it will return an integer. If one of them is a float, it will always return a float. You can also then add multiple values. And the clear function makes a slice empty, or a map. No, it makes a map empty, and a slice it will zero out each element.
Channel?
Channel, it doesn't work. I don't think it works. I don't think it's compatible with channels. I'm not 100% sure. I expected the slice to be length 0 afterwards. I don't think it is. So that's a good one to note, but very useful.
It can't be if this is a syntax, for sure not assigning the output of clear.
Well, it's a special operation.
It's a special operation. I don't think you have to assign it back to the original.
Well, yeah.
It's already easy to zero as slice.
Yeah.
One reason it doesn't do that.
Then 2 new packages. My favorite is the structured logging package. It's now available. We already had talks about. I highly recommend using structured logging for your production applications. And we have generics now for 3 major versions. And when they introduced it, they purposely said, we're not going to make any generic functions in our library because we don't know how to use them yet. They now do. And they made a slices package which has a bunch of utility functions to use slices based on generics. So you can reverse slices, etc., and do some other typical functions you would expect a language to have, which you might have been missing when starting out with Go, if you were coming from another language. I don't know. Too many more slides? 2 more. The loop var experiment is now available. One very known question, I don't think it's a bug because it was always documented, but in this case, it will always be 6 because it's the last element in the array, and your test will fail because 1 will never be tested. This previously was fixed by resetting v as a variable, so it wasn't reset every loop. And if you now mark Go experiment loop var, this will be default behavior in Go. You shouldn't have run into this if it's correctly, and this will probably be default in coming versions unless we now all find very broken things with this experiment. Interesting one, if you ever ran into it, you'll know. And then my favorite, I've been watching this very closely, the default HTTP package never had any variable substitution. The implementation is now ready. It was a proposal, it was accepted, implementation is now already available. If you run the Go tip, you can use it already. Basically, if you just use the built-in HTTP library for your routing, you can now add variables. Some things I didn't know and was thinking was surprising I wanted to share is you're not allowed to do this. It needs to be the whole part of the path. If you need to do this, do it afterwards in Go code. One thing I didn't know was already possible. You can use a host name in the path, and it will only match if that host name was this host name. This was already a feature in the HTTP library. New is that you can add methods, so it only matches the method you supplied. You put it in the same string to keep it backwards compatible. But the only exception that get will also matches the head function, so you don't have to do that yourself. And one important thing I always found confusing is this one. Anyone knows what it does?
Matches anything?
Sorry?
Matches anything?
Oh. Have you ever wanted to match only the root of your path, like just the domain, just the root, and then it matches on everything? And in the function you would have equal path equal slash, and then otherwise return 404. This will fix that. This will fix it. Normally, without this weird symbol, it will match everything, even if you add stuff afterwards. And with this, it terminates the matching. It's a confusing one, but an interesting one to learn.
It's like the regular expression end of.
Yes, exactly.
They use the same character as well.
It does, except for the brackets. I think that's it. And it adds to the request to new methods to access and set these. The setting is mostly done for testing purposes and some other edge cases they found while talking about this. I'm super hyped about it. Make sure to test it out if you want to give some feedback still time to do that. Before I do the thank you slide, there was just an update. Not going into detail, but it's very, very good idea to update your production services to this new minor patch because there's a big security issue that's fixed in there. Thank you for your time.
Yeah, no rest for the wicked. Nice. Okay. A year ago, I stood in Rotterdam in front of a group like you guys, and I was trying to convince everybody that Terraform programming is very easy. Does everybody know Terraform? Okay, amazing. So then what I'm going to tell you should be very familiar. You begin with the target API, but that you want to create your infrastructure in. In my case, it was typical Mashery. You have a very nice product from HashiCorp, and they have a standardized SDK, and what is left to write is a plugin in Golang. How hard can it be? Well, it pretty much depends on the complexity of the API that you're going to show, and in my fortunate case, because I'm working with enterprise and everything has to be super difficult, I have to create 5 levels of nesting until I can get to the thing that I actually need to do. This is kind of, that's what pays our bills. And I was telling to the group that I ran into one obvious problem, and that problem is mapping. It's enterprise, so there are a lot of elements, and it's kind of a lot of boilerplate. And there was one problem that I didn't tell to the group at the time that I was trying to build in Frankenstein. I'm Java developer, and I learned Go mainly to prove myself that architects still know how to code. And when I was looking at the whole thing, I'm just making a CRUD request. So everything in my head was saying, you know what? It should be repeatable. And kind of my background came up with structure like this until I started saying, you know what, guys, you know, these are just all interfaces behind it. So kind of there's literally nothing in the way to stop me shooting myself in the foot by passing wrong data in and out. And it kept happening. So 6 months ago, when I was doing a major infrastructure upgrade, a moment has come to say, hey, I can right now make a use of my work. Except it didn't work because I have broken the code. As you know, I was making it in my spare time, which pretty much you can figure out. You are all in off, you are forgetting what you're trying to do. You think it's a great idea. You didn't test it. Maybe kind of you forget about the edge case. Boom, production problem. And I decided, well, yeah, you know what? I need to go back and figure out, well, how to do generics and see if it's going to work. So guys, for those who don't know me, my name is Alex. I say that I'm everything architect. I can do all kind of projects. And essentially, what does it mean? It means that my full stack is reduced to essentially PowerPoint and Outlook. So if you're using mainly PowerPoint and Outlook, that you made it. Congratulations. And my talk today is Go generics or let go generics. And it's all going to be about trade-offs. And as an architect, well, architects never give you a straight answer, and I'm not going to give you either. And let me begin with the begin, because let's say generics go back to the beginning of times, to the times of Lisp. Does anybody know Lisp? Yes. Yeah, it started in the 60s. We're not going to talk about that. But then if you look at the timelines of major programming languages, you know, if they're so useless, why people keep reinventing them? And one thing that stands out is the TypeScript, because Microsoft didn't just go create generics, they created the whole generic algebra out of it, which actually works very nice. Yeah, and why do we do it? Because fundamentally there's nothing wrong with using interface. You want to prove? Silence. Do you want to prove? Yeah. Right. You use this programming language, well, maybe not as a programmer, but as a user, who will produce this. And you cannot remove, which one it is? Exactly, it is JavaScript. JavaScript will never have, yes?
Who said it's fine, sorry?
Sorry?
Who said that it's fine? Who said that it's fine? It's totally fine, but
Okay, so this is philosophical discussion. we can have it in the bar. Right, so JavaScript will never have generics, and we don't have a problem with it, so why bother? Okay, let's see why bother. Guys, can you get your phones and see if our small little quiz would do? Now is a tense moment. I don't know if it's going to work. All right? Is everybody ready? Yes. Okay. Now, finding the mouse. Okay. Let's see if we can get it here. Okay. It's like this. So the question to the group: have you written generic code before? Yeah, that's a very good question. It's something which buys you very nice Chinese today. So keep coming. Okay, interesting. Next one. Are you currently using generics in your Golang code? Unbelievable!
Rockstar star programmers here.
Wow, okay. Do you guys want to come to the podium and talk about generics? Okay, amazing. Next one. Do you agree that non-generified code is, or generified code, simple to maintain, straightforward to understand, easy to test? What's your opinion? Aha, we're getting somewhere. Yeah. So we're using generics, but and life didn't change. Well, quite interesting. Quite interesting. So, like, you know, I think 2/3 think that no change, and 1/3 of the group thinks that it has become easier. All right. So, last one. What's holding you back on using generics?
There's no knowledge about it.
Are you guys done? So these are quite interesting results. So for me, it is a bit of a revelation to see that you guys are using it. It's great. And I want to offer my perspective to convince you not to. Because if you said that you were not using it, I would try to convince you to use it. Yeah, obviously, you know, this is the architect's never a straight answer. So from my background, there are lots which you can improve on using the interface, and mainly if you're coming from the Java background, where generics has been around for 10 years, we're just used to generified code, because generics are all over the place. And essentially, after years of being indoctrinated into using generics, you kind of stick to the workflow of your code, that you define the concrete type, you define common capabilities, and you write it. And fantastic. And it is fantastic. Any Java code, any Java project that is using any sort of REST API would write a piece of code like this at least once, and this is JSON marshalling or almarshalling, and every project would contain it, and we do it automatically. So, kind of, you know, I can invent at any piece of my code a data structure, and I can just, you know, run it. Amazing. Until, as a Java developer, you start learning Go. And you said, okay, kind of, there is a standard almarshal, that's all fine. I said, what about if I need to almarshal 2? No, okay, it still doesn't look very bad. What about 3? Okay, I keep adding this stuff. What about 100? And that's the thing that occurred to me when I was doing the client library. I just realized that xdoclet would have been nice. Do you guys old enough like me to remember what xdoclet was? No. It was a Java code generation library which was thrown into the bin. But then even that would be better than manually typing. Another thing, and I'm showing to you kind of how Java developer would write a Golang code, and please make a good laugh of it. Because I'm proud, I'm an architect, I'm not supposed to be able to do this in the first place. Let's say I have a typed function, one of these that I showed you before. And you know, as Java developers, we're used to our factories or kind of common methods. What I realized, if I would just want to pass them in, I have to get the basic interface out. Which leads to an interesting code like this, where you have to pass in a function, and then you have to coerce the output of it to the type. It doesn't look very appetizing, right? Especially if you come from Java environment where you're used to all types polymorphism. Next to being an architect, I'm also a chapter lead in my company that I work for, and I periodically interview people. I do this for years. And from time to time, I would see people who say, well, I have Java and Golang experience, and I was asking them, what's missing? And that's what they tell me, generics, for years. Essentially, what they would say, well, if we don't have generics in our code, then we work for the compiler. We don't want to work for the compiler, we want the compiler to work for us. Which brings us to the whole philosophical discussion. What's the big deal with this third type of polymorphism, where you have to define these types, make it kind of super verbose, because it makes you go slower, literally. At the same time, an academic like me, like architect, would say, yeah, but you know, we define abstractions. We would define common algorithms. And then if you would practitioner, you would tell to me, well, you know what, it's not gonna work. And I thought, okay, how can I prove myself? Look, I'm going to show you a very simple code that will prove to you that generics are useless in modeling even the simplest of the problems, right? Let's assume you have two cars, one Audi, one Tesla, and they can write. You're following, right? Okay, so you can run a simple unit test. You're with me so far, right? And then you say, okay, I have two cars. I want to right now start kind of car dealership. I want to model it. Okay, right, looks like I need to invent the interface. So far so good. I have a vehicle and I can interchangeably pass back either Audi or Tesla because that's what I'll care. This is very good pattern, this is strategy, etc. Until you come to the thing which is called refueling. All right, obviously Audi and Tesla take different fuels. How would you model it? As a number. Works very well, but what about if you have multiple types? Do you want to type safety? Yes, we can take in the interface, but then we have to write this ugly piece of code that verifies it. But then from the interface perspective, that's nice. And the thing is, the moment you start doing something like this, you keep inventing ways that can shoot yourself in the foot. Because here, what I'm trying to do, I'm trying to put benzene 95 into my Tesla, but compiler doesn't know it because there's all interfaces. Until you run something like this and you're hopefully, you have a panic condition will tell that you're terminally intelligent. It will happen in production, and after the nth element, your tech lead will come to you and say, hey, look, we need to stop because this is what generics actually do. You're with me so far, right? You start kind of introducing generics, okay, you can write them in a different way. And hey, look at that. You've written generics, now compiler tells you that, hey, something's not right here. So they have helped you to stop writing a crashing code. Now you're forced to write kind of electricity which goes in. Another benefit is that you cannot just pass something that will break consumers because there is a type check. You can write a code that will consume everything. So, and Golang actually gives the generic type inference, so you don't have to repeat this verbose syntax. So it kind of collapses it automatically until you get a boring Java developer, like me, who asks you, all right, look, we have this interesting piece in the code. So I can take, let's say, vehicle, and I can swallow any generic, just any. Do you think we can do it? Everybody's asleep. I'm going to drop a mic. It cannot be generified. So now look at that. This was under 3 minutes. You have two cars. Can we assert the type of the fuel with generics? You just bloody cannot do it, and you go back to interfaces. So we have made a circle. Why did we actually start generifying in the first place? What would have worked with interfaces? Right. You know, I could have ended my talk right here. To say, well, kind of generics are useless, or kind of generic are useful depending on what your output of the poll would be. However, there is one thing that generics actually are useful for in virtually all languages that I have been programming so far. And they are what I refer to associated generic types. Essentially, you need to have two elements. You need to have very big domain, a lot of entities, and you need to have repeated operations that chain each other. Let's say you do one, then it produces something, and then you do again another operation on the output of the previous one, etc., etc. I'm going to show it to you shortly. This actually has worked brilliantly in my problem because what actually I had all along in my architecture, I had a central element, which CRUD operation template that was just doing like that. Those are the basics. So I was able to introduce just 3 generic types. So the type for what I'm sending up and down, this is the update insert, identifier of the parent object, and identifier of the object that I'm actually creating. And now I'm able to formally define the CRUD operations. And now compiler can start helping me out. So what does it mean the using associative types? Look at this. You can ignore the rest of the code because it's kind of error handling, kind of boring stuff. Let's say, first one, you have a Terraform state, and you want to figure out the identity of the object to read. So, state to identity. Second one, you want to actually go to the target API and fetch the current values. So you exchange the identifier for the current values. And kind of the third state is you take the actual values and you put them back in a Terraform state so that Terraform can do its magic. So look, kind of if you have to create 40, 50, 60 of these kind of things, this is the example of associated types. You have identifier, parent identifier, and the update insert. And you start getting a help from the compiler. And actually, you know, when I was showing this method, it pretty much looked like your standard Golang code, except it gets very, very, very verbose when you try to declare something. And these things become quite annoying in typing. Yes. Next thing that can happen, a bloat can happen, if you will simply start ripping off interfaces and replacing these with generics, you will start telling the compiler to generate bigger binaries. Where would it come from? This is the kind of example that I have found in the very code that I have written, which I think is very good, just to illustrate the principle. What it tries to do, it tries to talk to the API and do a bit of error handling and marshalling. But look at this. There is point number 1, where I actually try to do something useful. And there is point number 2. Okay, when I initially wrote the code, I thought that it would be a smart idea to do a bit of a backoffs together. Well, anyway, kind of makes sense. And then finally, at the very end, kind of also handling 404 together. So we have 3 different concerns, which are right now cramped into one method. And if I will have 100 domain objects, this code will be copied into the binary 100 times, which obviously bloats the size of the binary without actually you realizing it. This is the hidden danger of refactoring pre-generic Go code bases. You actually have to keep an eye on it. Well, it's possible to do. It's not that difficult, actually, because it kind of moving code here and there, but the message is it actually results in a much, much, much deeper refactoring that you can think. It's not just about put in a few times, you're done. Now, I know it's getting late, and kind of I didn't want to lecture you guys, so I want to add on kind of on a very nice bombshell so that we can go and have some exciting drinks. I want to give you 7 reasons to let go on generics. You ready? Yeah. So the first one is you like type and save code. Oh, obvious, you know, you can no restrictions, kind of, you're your own boss. You like rewriting things which are already rewritten, all right? Writing is rewriting, coding is recoding. Great stuff. Reason number 3 is that your tech lead has told you to clean up your code, and that's why you're not gonna do it, like your mom, right? Another interesting element is that you've heard about functional programming, but you think it is a fad because it has to do something with generics, right? We don't do generics, then we don't need functional programming. How many of you guys are good with testing? Raise your hands. Yeah, okay. How many of you kind of want to improve it? Your testing? Oh, all right. So the reason why you want to pass on generics is that if you have generic code, you can write generic unit tests. Okay, fine. Next one, I like this particular one. The worse the code, the better the job security. You know, interfaces, spaghetti code, and then only you are the only one who can do debugging in the middle of the night. And last but not the least, there is something that generics will always be unable to do. Ask any Java developer, ask any architect, ask any Haskell developer. There are always a trade-offs. They're good for something, but they are never good for the problem that you may be facing. And perhaps then the number 8 problem on the 7-number list. If you try doing this, your Go code will start stinking like Java, and this is exactly what we don't want to do. Probably that's kind of very, very strong that you can do. Now, I understand that 7 reasons to pass on generics might be a little bit too hard to remember. So I decided that I want to reduce it to one statement. Have you guys played this wonderful game, Plants vs. Zombies? Yeah? Did you like it? So in the discussion about do we need generics or not, I have realized that zombies actually were right all the time. Because choosing between to use generics or do not use generics, always go for brains. On this note, guys, that's all I wanted to share with you. I'm happy to take questions.
Is binary bloat actually a problem in this day and age? Because my binaries are like a couple of megabytes and then add another megabyte. I don't care.
Exactly. This is a very good question. I personally have not noticed it. But then it obviously depends on what kind of thing you are programming. Like I'm programming administration/infrastructure management, where size of binary is irrelevant and performance is equally irrelevant. But I can imagine if you would try to write for example, AWS Lambda function that would be sensitive to the cold start, probably you want to squeeze it a bit further. So it's it always depends.
But even then, the cold start would be like minimal impact with generic.
Exactly. So depends on how. Look, depends on how you deploy it. Depends on how you provisioned. Depending how your solution is engineered. So there are many considerations that go into. So essentially what you're waiting, okay, what is more important for you? The reduced cognitive complexities when you look at the function and you can figure out, okay, I have rough idea what it should be taken and I have rough idea what should be returning. Or you say, okay, I just want to remove all the impediments. I'm after the absolutely last bit of performance. Think what is more important for you, for the particular problem, for the particular project. Yeah.
Do you know if because we have generics now?
Yeah.
But things could change. Some
Yeah.
stuff could be added. I think there are some small changes. Now the latest release is some updates. But do you
Yeah.
know if anything else is coming or being worked on in Go generics?
Actually, I was researching this topic. What is happening? I have not found any kind of major updates on generics in the sources that I was able to find.
Yeah. Okay. So it's done.
Well, it is never done. I think at some point a few updates will be released, same as with Java and C. They all were receiving the updates, but let's say there are fundamental language constructions that cannot deliver the features, for example, that exist in C++ or exist in Java. And it will not be possible in Go, simply because the way the language is constructed.
I think there's now an active discussion on the topic of if you have a generic type, you want to access, if that's a struct, you want to access the members of that struct, which is currently not possible.
Yeah.
So if T here is some kind of struct with members, then and you have different struct with different members, you're not able to access them because that's just not allowed.
Yeah, okay.
Yeah.
But there's a discussion on that now to allow that in some form and make generics even more useful.
The biggest change to generics that I'm aware of is the 0 that was proposed and accepted for 122. That will make instantiating an unknown generic.
I want to use it for normal.
I do too. That's the only thing I want to use it for, really. It had big impacts and it came about because of the generic issue.
And wasn't there something about the binary bloat, the binary size bloat, that there was some kind of implementation detail about whether all these types for different T instantiations were going to be stenciled or created copies of all those types of functions, or if they're going to do some kind of smarter compiler code generation to not duplicate all those types?
Yeah, that's the whole thing about the compiler magic. So what Go specification says, the compiler might generate. Now, what is it might? So you need to decompile it and actually take a look what particular version of the particular compiler does. I have seen a few studies that people have actually tried to decompile into the assembly code and analyze the differences, what exactly is happening when you make a call on generified code versus non-generified code. And they figured out that In Golang, there are extra lookups on generified code, which technically speaking makes it slower. But then, kind of, it depends on kind of what you find as an impact. Maybe in your case, you just couldn't care less.
Any last questions? One once?
No?
Twice?
All right. All right. Guys, if you want to give the feedback, this is the algorithm. If you like it, reach out to me on LinkedIn. If you didn't like this talk, don't reach me on LinkedIn, reach me on Slack. On this note, we can close.
Thank you so
Yeah.
much.